Hi there everyone, and welcome to the last video on inequalities. This is when we step it up to what we call quadratic inequalities, and we're going to be asked to solve them. But before we can solve quadratics, we have to have a really good idea what the graphs or the functions look like. So you see I've written this word here in bold, which is function, and it basically means graph. So quite often what you may see, and if you haven't seen this already, you're going to see it quite a lot from now on in. Instead of writing a graph y equals, because we normally have x and y, we can also write, instead of writing this, we could say, well, the function of x is equal to. So function, you've seen the word many times, like function machines, when you had, oh, let's start with a 2. We put it in this box and we times it by 2. What do we get out? So you've seen function machines a lot. And that's just a fancy name for graph, a set of instructions really, and we can graph those. So take a minute, have a think, what does this function actually look like? What's it going to look like on this axis? And when you're ready, hit play. Okay, hopefully you came up with something along these lines, and don't worry if you have no idea, I'm going to explain it now. The important bit to make a sketch of any quadratic is how do we get these key bits of information. And what we mean by that is where it crosses the axes and the general shape of it and what it looks like. So, when you look at the highest power here, it's quadratic. And they're either going to look like a happy quadratic or a sad quadratic. And when it's a positive, this is just a 1x squared, that's a positive number, it's a happy quadratic. So for example, if it's a 2 or a 3 here, it would resemble the same shape. The minus 8 is the easiest bit. This is the y-intercept, it's the c value. And if you think about what's happening here, x is always 0, right? This is on the line x equals 0. So when you put x to be 0, these two terms cancel out and y is equal to minus 8. So the y-intercept is really easy. It's a constant term without any x's. But the harder bit is the x-intercepts. And what happens on the x-axis? This is where y is equal to 0. So to find out x-intercepts, all we have to do is make the y 0. But then we get to a bit of a problem. And this is when you have to think, oh, I've now got an equation. I'm asked to find x, so that means I'm solving it. And because it's quadratic, we need to get everything on one side, which it is. And then we're going to think of either three things: factorizing, completing the square, or using the quadratic formula. All of those are great choices, but I would always go through in that order because it's the easiest. So, are there factors of 8 that make 2? Yes, there are. Okay, so let's set out our brackets. Oh, and it's a double bracket. I could give you single bracket ones of these, but because there's nothing common to all three terms, we know it's a double bracket problem. So the factors of 8 that make 2 are 4 and 2, and we do that by doing 4 take away 2. And if you look at these last terms, the signs are different, and they have to be different to have a product of minus 8. So now we have a multiplication problem. That's what factorizing does. It takes it from addition or subtraction to multiplication. And the multiplication has to equal 0. So if I make this bracket 0, x would be minus 4. And if I make this bracket 0, so 0 times whatever this is, I would get 2. Lo and behold, you can see they are my x-intercepts. Okay, so that's how you sketch them. That's really important. So the question is going to look like this: solve the inequality. Now you can see the wording's slightly changed. We don't have an equality now. It's not an equal sign here, it's an inequality. Okay, now, oh, excuse me, my phone's ringing, hang on. So you can see that I've done exactly the same bit of working, and I've got the sketch here, and the sketch is really important. Now, what we call these are critical values, because they are critical for me to make the right decision now. Now, what this is saying is this function, this graph, where is it below 0? So if we have a look, this on this line here, this is where the function of x is equal to 0, because when we set it equal, we got these two values. So below this line, this is where the function of x is lower than the 0, and above the line, this is where the function of x, the function we're looking at here, is greater than 0. So we want the area where the function of x is less than 0. So if I get my highlighter, all the values that are less than 0 are below this x-axis. So we can say with confidence, oh, that's a highlighter. So when we look at values lower than 2 on the x, so all of these values in here, the function is below the line. And when we look at all the values greater than -4, okay, so that's one done. Now what we're going to do is we're going to look at the same question, but I'm going to just swap this sign around. Okay, so have a look, it's just up down below. So all of this is what we just done before. So now all I've done is swap the sign. So here's my sketch, but we want now all the values greater than 0. So if you remember, I just said the values of the function that are greater than 0 are above, where it's equal to 0. So now it's the same drawing, the same critical values, but now we'll be looking at these areas here. So that is going to happen, same mistake again, apologize, when we look at x values lower than -4. So for example, if we go to -5, the line, this value here, when x is -5, is above y equals 0. And all of these values here will give values on the graph, on the function, that are above the line. The same thing happens when we go to the right hand side of 2. Everything to the right of 2 is above the line. So when x is greater than 2. And while we're here, if I put this equal sign on here, that means it can equal as well, so it's less than or equal to, so we would just add those on. And if I did the same here, it can also include the x-intercepts. So let's have a look at a few more, and by the end of the video you would have got it. So what you have to do is solve it in a normal way, and I'm actually going to change it to an equals. So I don't do that when I solve a linear, but I am going to do that when I solve a quadratic. So I get my two values, x equals 3 and x equals -2. And these are my critical values, so always write critical values. You then must do a sketch. It's a happy quadratic. I'm not actually interested too much in the y-intercept for this question. I actually only need to know these. I've got one on the left hand side, one on the right hand side, and it doesn't have to be accurate. So I can go -2 and 3. It's just some information to help me. And I'm looking for where the function is lower than 0. So remember, this is where the function is equal to 0 on the line. So when we change it to equal 0. So below the line is when the function is less than 0. So that is the area we're interested in. So that is when, one day I'll stop making that mistake, that is when we're looking at x values lower than 3 and greater than -2. If you still haven't got it, don't worry, we're going to look at about 9 questions in total. This is the same question, but with the arrow pointing to the right. So if you remember, my sketch was, let me just check it, -2 and 3. So -2 and 3. And now we want where this function is greater than or equal to it. So it's equal to it on the line, y equals 0, and it's greater than 0 above. So if we look at this one, we can say x is greater than or equal to 3, because we're looking at these values here, and we're also looking at these values here, so we can say all the values less than or equal to -2. So we have two answers there. So anything in between, the function is lower than 0, whatever that sign is there, just if it has the equals, it has the equals in the answer. But what you mustn't do is just keep that sign. You can see it's changing direction, and that's where you must use your critical values and draw a critical value sketch. Okay, question 3. So we're going to factorize. This isn't a factorizing video, so I'm going to do that bit pretty quickly. Change it to equals. Find my critical values, so x is 5 and x is minus 2, because I've solved the quadratic, I've solved the multiplication problem, made them both 0. Make a sketch. One's negative, one's positive. I'll try and make it roughly resemble what it should look like. I'm not paying attention to the minus 10, but if I wanted to put it on, I could put minus 10 in here. And I'm only interested in where the function is lower than 0, so that is now below where it's equal to 0. So this is the only area that I'm interested in, and that's when the x values are in between these two values, in between those. And you can see how I've tried to do it underneath. I just think that's pretty helpful. Question 4. So this is much the same, but now we're looking at greater than 0, so we're going to be looking above the line. So we're going to solve it. So the factors of 21 that make 4 are 7 and 3. Product and sum equals, write down my critical values. So we've got minus 7 and 3. You must do a critical value sketch. It's going to look something like this. And again, if I wanted to put the y-intercept on, I could, but actually I think it doesn't help when you're doing these. So we are looking above the line, here and here. So we're looking at the values greater than 3. I'm not putting the equal sign because it's not in the question. I don't want it on the line. And we're looking at these values here on the left, which are below 7. So you have 2 answers. Question 5. Exactly the same. So let's factorize. So we've got minus 5 and minus 1. This one's going to look ever so slightly different, and you'll see why in a minute. So critical values, x equals 5, x equals 1. Critical value sketch. The only reason this one looks different is because they're both on the same side. So I put my x, put my y, and we're interested when they're on the line and above the line, because it's greater than or equal to. So we've already worked out where it is on the line, so we're looking at values greater than or equal to 5. If it's equal to 5, it's on the line, so equals 0, and if it's to the right of 5, it's greater than 0. And we're looking at the values less than or equal to 1. So hopefully by now you're getting the gist of things. So maybe have a go at pausing the video and hitting play when you're ready. Aha, this one is dots, so x plus 7, x minus 7 equals 0. Critical values are minus 7 and 7. Oh, I didn't put the minus on, there you go. Critical value sketch. It's going to be a nice symmetrical one. And we're looking at the values less than or equal to. So with my highlighter, I go less than or equal to. So in between 7 and minus 7, and just making sure I've got the equal sign on my inequality as well. Again, pause the video if you think, if you think you can, but I haven't spoken about these. And what you can see is I've given it to you in the factorized form, so we're starting basically from here. Okay, so if you thought about expanding it, you're just going to add another layer on, and that's what the question will look like next. So once you're in that factorized form, you then go ahead and solve it because it's already in the multiplication phase. So how do we make this one 0? You might want to take your time. So 2x plus 1 is equal to 0. So 2x is equal to minus 1. So x is equal to minus a half. This is my first critical value. This one's slightly easier. We can see x is going to be equal to 3. Make my sketch. It's going to look something like this, that being 3, that being minus a half. And we want all the values lower. So we want them, we want all the values below 0, which are here. So how do we write that? So we use a compound inequality, and we're looking lower than 3, but bigger than minus a half. So you may be thinking now, well, we're only ever before interested in integer values. Well, we're not really. It's just if we ask you a question, find all the integer values, then obviously you're not going to include that. But you need to appreciate there are an infinite amount of numbers between any two sets of numbers. So we're going to write it like that, but if they then maybe in a part B say list the integer values, then you would start at 0, 1 and 2. Okay, so this is the last one. Now this is a harder type of factorising, and there's two ways really of doing it, and maybe I'll talk about them separately. So the first way, we're going to we'll use the quadratic algorithm. Okay, so we're going to look at the factors of 12, so it's the AC method. Okay, so we're looking at the factors of 12 that make 11. So I think you'll agree that's 12 and 1. So if we did minus 12x plus 1x, you'll see that this part here is the same. It's just a rewrite. I've not made it any bigger. And if you don't know the AC method, then this isn't the video for you, and you need to learn that first. So then we factorise in parts. We factorise the first part, in pairs. Factorise the first pair and the second pair. So we can see the first pair has a highest common factor of 3x, so we can take that outside. And the beautiful thing about this method is both brackets should be the same. Right, it's annoying when this happens because there's no highest common factor other than 1, so we can take out a 1. If that's a plus, just pop a plus here. Now the brackets will always be the same, so sometimes a good idea is to put the same bracket and just expand it. So I've got 1x, check, and minus 4, so that worked. And let's change that to an equals. So we end up with 3x plus 1, that's, I'll explain this in a bit better now. So we've got 3x being multiplied by x minus 4. So if you think about expanding this, you would do 3x times x and 3x times minus 4. So that's the same. And we've also got 1 times this bracket, and that's what would happen when you did the second inner and the last term. Okay, so this is an equivalent way of writing it. You can think about it as the highest common factors are in one bracket and the repeated bracket is the other one. So let's find the critical values. So we're going to have x to be minus a third using the same technique I spoke about earlier, and x to be 4. We're going to make a sketch. Minus a third and 4. And we're looking at less than or equal to. So we're looking at on the line and below the line. So my answer is less than or equal to 4 because it can be on the line, and more than or equal to minus 1/3. So earlier I mentioned there is another method, and it's to skip basically the AC. And I would always skip it because one, it's how I was taught, and I only use the AC method if it's going to be difficult for me to do this. Now this is prime, so there's only one option. It's 3 times 1, or 3x times 1x. This is where the difficulty lies, because I could put a 1 and a 4 here, or I could swap those around and put a 4 and a 1. Or the other option is 2 and 2. That's it. Now this method is only good if you're really quick at expanding using the outer inner FOIL method. So let's go back to the first one. So in fact I'd always try the middle one, so let's do this. So you can see here I'd have 6 and 2, so that doesn't make 11, so I could just quickly rewrite it, but because I can delete it I will. Let's then go 1 and 4, and I go 12 and 1, boom, I've done it. Okay, and I get minus 12 plus 1. So in my head, basically, I would go all the way to this stage straight away, and then there's the rest. So you choose your method. You do trial and error. It's really useful if they're primes, and quite often they're both primes, so there's only 2 options. Or if you don't like it, you use the AC method. There you have it. So good luck. I'll be on Teams if you need me, and yeah, you just got to practice loads of these, so best of luck.